Okay, so here is Unit 2, Day 2a, and this is about a function called a power function. I'm not sure if you've ever heard of that before, but all it is, and it's part of our learning target here, I can sketch power functions in this form. So it would be k is a constant, and then x is a variable raised to some power. And that makes it a power function, and k and a both need to be rational numbers. Rational just means they could be written as a fraction or it can be a whole number. Yeah, so down here, any function that can be written in the form, we just said that again, is a power function. The constant a is the power, so a is the power, k is the constant of variation, or constant of proportion, we call that. And we say f of x varies as the 8th power, a power, of x, and f of x is proportional to the 8th power of x. It sounds like 8th, like the number 8, but it's not. It's 8th power. So analyze each power function using the terminology from Unit 1. So think of these as parent functions. Okay, so think of this. This is the cube root parent function, and this is we call it reciprocal squared function over here. So why is this a power function? Well, think of it first. If we write this, instead of the cube root, think of it as x to the 1/3, and then think of it as a 1 out front. So in this case, that k out front equals 1. The power is 1/3, so that's why it's a power function. Okay, and then this guy over here, I could rewrite this, bring this to the top, and when I do that, it'd be x to the -2, and again, the number of front would be a 1, so k equals 1, a would be -2. Now let's graph this. We're going to graph this function using 5 points. So let's just make x, f of x. I don't want to just put -2, -1, 0, 1, and 2 because I'm cube rooting. So I want to pick x's that are easy to cube root. So a really easy number to cube root. Well, first off, 0 is easy to cube root because the cube root of 0 is 0. And then 1 is easy to cube root, 1. But 8 is the next number that's easiest to cube root, and that would be 2. Notice I skipped the negatives, but can I do negatives? Can I cube root a negative? Because is a negative times a negative times a negative, can I get an answer? Absolutely. So -1, the cube root of -1, and this one is -1, because -1 times -1 times -1 is -1. How about -8? It'd be -2. Because if you took -2 times -2 times -2, you do get -8. So sometimes we see roots, we think, well, we can't root everything. We can't square root everything, but you could cube root anything. And if I plot these guys, so 0, 0, 1, 1, and then 8, 2, I get this shape, and it actually kind of goes smooth like this. It's a curve. It's not a little jagged. It's kind of a smooth curve through there. And then we can just do these down here real quick. So the domain and range on this goes left and right forever, so -infinity to infinity. Also the range, it goes up and down forever, so -infinity to infinity. The symmetry, what kind of symmetry does this have? Again, remember, it's not about the y-axis, it's not about the x-axis, but if I rotate this 180 degrees, I get the exact same function. So this is about the origin. So we could say odd or origin. Kind of mean the same thing. Boundness, does anything bound this from above? Now it kind of looks like it's flattening out, but it does keep going up forever. So nothing from above, nothing from below, so there is none. Any asymptotes? None. There's no lines that this has to follow. Discontinuities? Are there any discontinuities on this guy? There we go. Just trying to get that focused correctly. Discontinuities? None. There's nowhere where it's discontinuous. Increasing, decreasing. Now this one it's actually from left to right. It's always going up. Always going up. So this is increasing from -infinity to infinity. Decreasing, none. Never. Okay. And then extrema. Does it have a maximum? Well, it can't have a maximum or minimum if it's always increasing. So this one is none. The other guy here now says label 2 points and asymptotes. I might do more than 2 points. And the asymptotes too. So generally, if you start out with your 0, well, what is 1 divided by 0 squared? Well, that's undefined. So right there, we've got our asymptote. Okay, I should say it's either an asymptote or it's a hole in the graph. And I'll just give you a hint. This was an asymptote. So right here, there's this asymptote. If I plug in 0, I don't get an answer. So there's a vertical asymptote at 0. And then I'll plug in -1, -2. So this would be, if I plugged in -1, that'd be 1. If I plugged in -2, it'd be 1/4. Now I'll plug in 1 and 2. So that would be 1, and that'd be 1/4. So if I plot these guys, -2, 1/4, it's about right there. -1, 1. Kind of looks like this. And then what's going to happen here, it goes up, 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 up really fast, off to infinity on both sides here. What's going to happen down here though? Can I ever have a negative answer? Can I take a positive divided by something squared and get negative? Well, something squared is always positive, so positive divided by positive is positive. So this actually flattens out like this and stays above that x-axis. Okay. Apologize, this got jumbled up down here before I printed so this should be over more. But domain on this guy, well, I can plug in anything except for one value, because this goes left forever and right forever, but there's that 0 in the middle. So from -infinity to 0, and from 0 to infinity, we're good. The range, up and down, it starts at 0 and goes up forever. Symmetry, this one is even. It's about the y-axis. The boundness goes up forever, but it doesn't go down forever. So it is bounded. It's bounded by y equals 0. And it is bounded, we could say it is bounded here, going this way too, at x, or I'm sorry, at x equals 0. That asymptote could be a bound. I'm sorry, no, I got this wrong. Asymptotes. So my asymptotes are y equals 0 and x equals 0. I'm getting ahead of myself. This is just y equals 0 from below. Okay, now this one, yeah, this is y equals 0 and x equals 0. So there's your asymptotes. There, set of crosshairs. Are there any discontinuities? Yes. There's one of those. It's an asymptote, so that's a infinite discontinuity. Infinite discontinuity at x equals 0. Is it increasing or decreasing? Well, it's increasing from -infinity to 0. And here 0 is not included because it's not defined there. So that's one of those times we don't include that number. If it were a maximum, if it was a maximum point like this, at that point it's increasing and decreasing. But this is an asymptote, so it's not increasing at 0. It's not decreasing at 0 because it's not defined at 0. And then decreasing from 0 to infinity. And then the extrema, there's no minimum, no maximum, so none. Okay, so none. Okay, and at the top here, we're going to graph some power functions, and it just talks about the key to the power function is the exponent. If a is positive, if a is a positive even number or a positive odd number, you already know what it looks like, a quick sketch of the parent function. So use your knowledge of parent functions to fill out this first column. So in this first column, this guy right here, if a is greater than 1, so if these are all positive exponents, if it's even, like y equals x squared, x to the 4th, x to the 6th, they all have kind of the same shape. X squared is a U shape, and x to the 4th is just going to accelerate faster, so it's going to be going up quicker, so it's going to be more like this. It's going to have higher numbers faster, and then to the 6th is going to be even more, but it's going to be U shapes. Okay, and then if it's odd, like x cubed, x to the 5th, x to the 7th, it kind of has this shape. So x cubed kind of goes like this. If it is x to the 5th, it's going to have bigger numbers faster, so it's going to be a little bit skinnier. and x to the 7th, just like that. And if you don't trust me on these, you can always graph them in, or put them into a graphing calculator and check it out. Now use your graphing calculator to graph these guys and fill in the second column of your charts. You're not supposed to already know this, just fill them in. So maybe I'll let you do these, do this one, and do B and C, fill these in, using those numbers that you have in front of you. And if you're kind of stuck, here's the numbers I'm going to use. And when we get to the x to the negative x squared, that's the one on the front side of this paper. Looks something like this. And now x to the negative 4th is actually going to have smaller values here, and it's going to cut in and go like that. Smaller and cut in. And then cubed would be even smaller and cut in like faster. Something like that. And then down here, these guys are going to, instead of being both on top, they're going to be alternating. So this looks something like this. Okay. Again, they kind of crisscross. Oh, I'll read the last one out. And then if it's less than, or yeah, if it's these are going to result in roots, because x to the 1/2 power is actually the square root of this, the 4th root, the 3rd root, the 5th root. So these are the ones, like when it's an even root, it goes like that. And then if it's a 1/4 root, it's going to be a little bit smaller this way. And then if it's a cube root, it goes like this. And then if it's a 1/5 root, it's going to go in like this and kind of do that. Okay, so that was B and C. Now go back to the functions given on the front side, rewrite them in this form, which we already did that. We already rewrote those in that form. X to the 1/3, x to the negative 2. Which part of the graph do they match with? So we can say like A, B. So this was x to the 1/3, x to the negative 2. And x to the 1/3 would be in this one right here. So that would match with the 3rd column bottom. And then negative 1/2 matches this guy here. It had the same so we'll say middle, top. Had the same general sketch. Okay, so now take the bottom here, take a few minutes, try your best on this, and match those guys up. Now, there's a little trickiness to it, but do your best, match them up. It's not going to be perfect. You're going to struggle at some point with them, but match those up, and then hit play, and we'll go through the answers. And first thing you'll notice, I do have a couple of repeats here. I did I twice, I used D twice. So if like this guy here, the first one, it has x to the 4th power, so that's going to be, it's a positive even power, so it's going to be kind of a U shape to it. So think of a U shape, and granted we're missing half of it here, but then the negative would flip it over, so it's going to be, actually it's going to end up being like this for the I shape, or for number 1. This one is to the negative 5th power, so it's a negative, which means it's going to be opposite sides. Well, we're going to be able to count one of them, and has a 1/2, that's okay, but it's going to be one of these guys. Okay, so even though it should be, the other half would be down here. The 3rd one here, we got a 1/4 power, which I think 1/4 power looks like that square root, but a little bit less shallow, and that goes with D. So 2 would just make it taller, but it's still going to be that general shape. You got x, so you got negative x to the 5/3. Think of that as x to the 5th and then cube rooting. Or you could think of it as x to the 1/3 to the 5th power. Maybe that's an easier way to look at it. So the 1/3 is kind of what's going to really do it. So 1/3 looks like this, kind of does that shape, and then this one's going to get flipped over, so it's going to go like that. So that's why it looks more, in this case, let's see, more like I. So it was kind of going that way, now it's going this way. And then J has a negative 2 power, so that's one of these guys up here. And so it's kind of like this, and it gets flipped over, so that's why it ends up being J. Let's see. Yeah, So it was like this, gets flipped over, so that's j. And then the last one, again, think of this as x squared to the 1/3. So squared, and then the third power is going to make it smaller, a little bit smaller. But that would match up with d then. Actually, I got these backwards. I'm sorry, x, and this would be a 1/3 squared. I want to do it that route.